All right. So, if we want to separate two substances via filtration, we have to look at their solubilities. We cannot separate two things that are both soluble in the same substance. Okay? Let's think now about how we would separate X and Z. So we know how we could separate either these two or these two. How would we separate those two? Okay, let's look at some other characteristics. What are some physical characteristics that you have used to separate substances? Heat. Okay, we can look at heat of vaporization. We can look at things like boiling point. So let's look at just that. Heat of vaporization, also sometimes called boiling point. This is the temperature at which a substance is going to go from either being a liquid or a solid to being a vapor. Okay. What if we have a heat of vaporization of 115 Celsius, 110 Celsius, and 575 Celsius? Okay. Can we easily separate X and Y by heating? No. Got a very narrow range. You're going to have a real hard time. In theory, if you heated it to 113 degrees, all of this will vaporize and you will be left with this. In reality, that's going to be almost impossible to do in a lab. Okay. Could you separate these two by heating? Yes. And if you heat a combination of these two, then which one's going to be driven off? Which one is going to vaporize? Y. Y is going to vaporize at a much lower temperature. You'd have to get that one really cooked to get it to vaporize. In the lab you did yesterday, which substance had the lowest heat of vaporization? The ammonium chloride. You're able to heat it under the hood on the hot plate and drive it off as vapor. So this is the idea of using characteristics of the material to separate. Now let's think about something else. In this case, so if you are given X, Y, and Z in a mixture, you have two processes here that you can use to separate those three things. Which process do you want to use first? Okay. Why are you going to use filtration first?
Then you can get X and Z by themselves.
Yeah, because then you've got X and Z by themselves. If you vaporize first, so your first step is going to be to add acetone. I was afraid the iPad fell over. Add acetone and filter. Okay? After that, what will you end up with? Okay, you're going to end up with Y and acetone in the filter. You're not going to end up with just Y. It'll be soaked in acetone. What else will you end up with in a beaker someplace?
X and Z.
X and Z in what?
Acetone.
In acetone. Okay. Now, fortunately, acetone is what we call a volatile substance. We'll talk more about volatility later in the year. A volatile substance is one that has a very low heat of vaporization. So acetone is going to evaporate off at room temperature, 25 Celsius. And if you've ever spilled acetone on your skin, taking off nail polish, it evaporates very quickly. It leaves a cold spot on your skin because of that. So we don't have to heat this too far. We could heat this to 30 Celsius, 50 Celsius. I mean, low temperature heating here. So let's just say we'll heat it to 30 Celsius. I have to look up the exact, let's assume that acetone evaporates at approximately 28 Celsius. So we heat it to something over that. That's an assumption. That's a pulled out of thin air. Then we're going to be left with Y by itself. Okay. Here, what will we have to do to separate X from Z?
Vaporize.
Gonna what?
Heat out X.
Yes, we're gonna have to heat it. And what temperature will we have to, I still couldn't quite hear or understand.
It's on the screen.
Oh, well, that's okay. It'll have to do. Or wait, maybe I could do, is that on the screen?
Yes.
Okay. That will help you more if you have to go look at this later tonight. Okay, so to what temperature will we need to heat that combination of X and Z?
115 Celsius, a little bit higher than that.
Yeah, something over 110. So, we can heat it to 112. We can heat it to, oh, I'm sorry, 115. My apologies. Okay, so we have to heat it to something over 115. So, 117 degrees Celsius should get us what? Okay,
Vapor.
we're going to have
X is vapor.
X vapor,
And Z.
and we're going to have Z as a solid, and that should also drive off the acetone, so we won't have any acetone left. So, can you build a flow chart based on properties for separating two substances? I think you can. I think you can. Okay, questions on that? Okay, good.